Good morning, this is Dr. Turner for Integrated Math 1. Today we're getting into 9.2, which is looking at isosceles and equilateral triangles. We're going to take a little bit of a review here at the beginning and look back at how do we classify triangles, and then we'll get into some theorems that apply to isosceles and equilateral triangles respectively. Again, we're trying to simplify it because we're doing everything online right now. If we were in person, we would be doing two-column proofs involving isosceles and equilateral triangles, but I want you to just focus on the fundamentals right now since we're doing everything online. But let's go ahead and get started. So first off, we want to be able to classify triangles. And there are two ways of classifying triangles. The first is classifying based on the angle measurement. And then the second is to be able to classify based on the sides. So first, by classifying by angle measurement, if you have an angle anywhere in your triangle that is greater than 90 degrees. So for instance here, if we have an angle that is greater than 90 degrees, that is an example of an obtuse triangle. If you have an angle that is exactly 90 degrees, and it doesn't matter how it's oriented, it could be right side up or upside down, but if you have an angle that is 90 degrees exactly, then that is an example of a right triangle. And if all of your angles are less than 90 degrees, then that is an example of an acute triangle because all the angles are acute. So just like an angle, when you're classifying an angle, you classify triangles the same way based on angle measurement. So obtuse is where you have an angle that is greater than 90 degrees. A right triangle is where you have an angle that is 90 degrees, and acute triangles have all angles that are less than 90 degrees. That is one way to classify the triangles. The other way to classify triangles is based on the sides. So the first is an equilateral triangle, and again, bear with me because we're doing this all on the computer. It's not necessarily drawn to scale. But if all the sides are congruent, and you could notate that by showing the congruency symbols, then that is an equilateral triangle. If you have a triangle where two sides are congruent, then that is an example of an isosceles triangle. Again, typically notated by congruency symbols. And then if you have a triangle where all three sides are different, and again, it doesn't matter which way your triangle is oriented, but if all three sides are different, just something like this, for instance, where all three sides are different, then that is a scalene triangle. So technically, if you were asked to classify a triangle and to be as specific as possible, there are two classifications you're giving. One based on the angles, two based on the sides. Now we're focusing on equilateral and isosceles triangles here in 9.2. So it's important to note that in an equilateral triangle, because all of your sides are congruent, all your angles are congruent as well. Remember your triangle inequality theorem from last year where we said that if you're looking at a triangle, the largest side is always opposite the largest angle, the shortest side is opposite the shortest angle, etc., etc., etc. And as an extension of that, if you have all three sides that are the same, the only way that works is if all three angles are the same. Similarly, with isosceles triangles, if you have two sides that are congruent, then the two angles that are opposite those sides are also congruent. So equilateral triangles have three congruent sides and angles, and isosceles triangles have two congruent sides and two congruent angles. Scalene triangles, all sides are different, which means all the angles are different. So that's how you classify triangles based on angle and sides. We are focusing on, again, equilateral and isosceles triangles. So there are a couple basic problems that you could be given with equilateral and isosceles triangles. It might be as simple as, if you're given a diagram, it doesn't matter which way it's oriented, it could be upside down. But if I tell you this is an equilateral triangle, and let's call this, we'll call it triangle QRS. And if I say QR is 10 centimeters, and I give you that it's an equilateral triangle, then I could ask you questions. Well, what's the length of QS? If it's equilateral, it's also 10 centimeters. What's the measurement of RS? It's equilateral, so it's also 10 centimeters. Now, you can have similar problems with the angle measurements. However, in an equilateral triangle, because all three angles are congruent, and the angles of a triangle have to add up to 180, for any equilateral triangle, the angles will always be 60 degrees. So if I tell you that the triangle is equilateral or equiangular, every time the angles have to be 60 degrees. So you might not even be given one of the angles because it's implied for an equilateral triangle that all three are the same and all three are always 60 degrees. Similarly, with an isosceles triangle, I don't know why it's drawing upside down today, but that's okay. For an equilateral triangle, if I tell you that triangle FGH is isosceles, and I show which two sides are congruent based on those measurements, then I could tell you, okay, well, if FG is 18 feet, I could ask you what the measure of GH is. FH rather, would also be 18 feet. So those are sort of level 1 problems, right? You're just identifying what type of triangle it is, and based on the definition, it's the same number, whether it's equilateral or isosceles. So there's no real algebra involved in solving those types of problems. Similarly, in an isosceles triangle, if I gave you, let's say, the measure of angle G as being 72 degrees, and I ask you for the measure of angle H, because these are isosceles triangles, remember that the opposite sides have to match up with the opposite angles. So, therefore, H in this case would also be 72 degrees. Now we can throw in a couple questions involving 9.1 or any lesson that we've covered so far. So it would be fair game to ask you what the measure of angle F is also, knowing that, by definition, H has to be 72 degrees. And then to determine angle F, that would be 180 minus the two angles we know, which would add up to 36 degrees. Okay? Just like we did in 9.1, you can have some questions thrown in that involve algebra instead of integers. So for instance, I could give you, let's say, an isosceles triangle. We'll call our triangle here ABC. If I give you that ABC is an isosceles triangle, let's say AB is 12x and AC is 2x plus 80. I could ask you for the measurement of AB or BC, or I could ask you for the value of x. So let's say, for an example, I ask you to find x. Because it's isosceles by definition, these two measurements have to be equal to each other. So I can set up an algebra problem, 12x equals 2x plus 80. Subtract 2x on both sides, and divide by 10 to get x equals 8. I could also ask you for the measurement of AB or the measurement of AC. They're the same. So if I do that, then you plug in 8 back into the equation. Doesn't matter which one. If I plug it into 12x, 12 times 8 would give me 96. And then if you are given units, centimeters, inches, etc., then you would solve that. Similarly, if I tell you the measure of angle B is, let's say, 3x, and the measure of angle C is 2x plus 20, I could ask you to solve for x, or I could ask you for the measure of any of those angles. So, and that's fine. Again, it's not always to scale. 3x would then be equal to 2x plus 20 because this is an isosceles triangle. Subtract 2x, you would get x equals 20. And if I ask you for one of the angle measurements, then plug it in. 3 times 20 gives you 60 degrees. So some questions will involve integers, some questions will involve algebra, but the setup is the same. Equilateral triangles, all the sides are the same, all the angles are the same. In isosceles triangles, two sides are the same and two angles are the same, but specifically the angles have to be opposite the two sides that are congruent. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon.